All right, so this is the video answer key for your trigonometry review. So feel free to skip around. There also is a PDF document in the folder, so you could use that as a quick reference. But this will show you step by step how to solve these problems. Your exam will be very much like this review. So the first problem gives you an angle theta that's 45 degrees, and I want you to find the complement. So we know that the complement means it's going to add to 90 degrees. So let's just call the complement x, and 45 plus what number equals 90 degrees? Well, that is 45 degrees. So angle of 45 degrees is its own complement. Supplement means they're going to add to 180, so 45 plus some number x is going to equal 180, and so then we will subtract 45 from 180. That'd be 140 minus 5, which would be 135 degrees. So the supplement to 45 degree angle is 135 degrees. So problem 3 asks you to use similar triangles to find the distance across a river. And so the shortest distance, of course, is this length CD. And like if you were going to build a bridge, that's where you would build it. And so we want to use similar triangles. How do we know these triangles are similar? Well, we know it's a right triangle, and so they have two angles. So by angle basically, because 90 degrees and 90 degrees, those are similar. And then we also have these vertical angle pair here, which is also congruent. Rather, not similar. I use the word similar. So 90 degrees is congruent to 90 degrees. The vertical angle pair is also congruent. So by angle, these are similar triangles. So I know that the sides are in proportion. So I can say that if I have the ratio of, there's several ratios you could set up. I'm going to do 14 to 8 in the first triangle. So if I say the vertical distance 14 to the horizontal distance 8 is going to be the same as this vertical distance. I'm going to call the CDX is what I'm looking for. So x, which is the larger distance, to the horizontal distance 20. And so when I calculate that, it should give me the distance across the river. And so I'm going to take 14 times 20 and divide it by 8. And so you can do that. I'm going to simplify first. So if I do 4 goes into 20, that's 5 times. 4 goes into 8, 2 times. 2 go into 14, 7 times. And so this will be, x is going to be 35. And so this is a distance of 35 meters across the river. There are other ways you could have set that up with a different proportion. You stayed in one triangle. You also could have set it up. I could have said 8 is to 20 as 14 is to x, and that would have given the same answer. So I would have had 14 times 20 divided by 8 as well. So there's more than one option. All of them, if they're done correctly, will give the answer 35 meters. So in problem 4, it asks you to look at angle A, which is here, and find the sine of A, the cosine of A, and the tangent of A. So in your notes, you should have the ratios. The sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is opposite over adjacent. And so using those 3 ratios, we should be able to find this out. 25 is the hypotenuse, so that's going to be, wherever we use hypotenuse, will be 25. When I'm looking at angle A, the opposite side is 24. So this would be 24 over 25 would be the sine. That does not reduce. The cosine is the adjacent side of A, which is 7 over 25. And then the opposite over adjacent would be the 24 over 7. And again, that does not reduce. So problem 5 says if I have the sine of 37 equals cosine of theta, how do I know what theta is? So the sine of 37 equals cosine of theta. Well, I know that if the sine is equal to the cosine, then they're complementary angles. So I know 37 plus theta has to equal 90. And so I'm going to take 37 from 90. So 90 minus 30, that's 60. 60 minus 7, that's going to be 53. So theta would be 53 degrees. Remember, if you know the sine is equal to the cosine, then the two angles are complementary angles. So now we have this guy, Gustav, I guess, and he's looking up in a large oak tree. His eyes are 5 feet from the ground. And that's important because if we want to know how the question is how high that owl is up in the tree. If I want to know that, I'm going to have to add 5 to whatever my answer is, because this little triangle here is going to give me the height of the owl above his eyes. And so we know that the adjacent side of this triangle is 15 feet because he's 15 feet from the tree. And I also know that the angle is 30 degrees. So what I'm looking for is this opposite side of the triangle, and I'm going to call that x. So opposite and adjacent, that's going to be tangent. So if I take the tangent of 30 degrees, it's going to be equal to opposite, which is x, divided by the horizontal, which is 15. So the length of the owl, the distance above his eyes that the owl is going to be 15 times the tangent of 30 degrees. So we'll do that on the calculator. Remember, you need to make sure it's in mode degrees. That comes out to be 8.66, and of course it keeps going after that. So this is, all these measurements are in no decimals, but I'm going to round this to a half, so or to the tenths place rather. So this would be 8.7 would be this distance that the owl is up here, x. So this is 8.7. This distance here. So the total distance, the distance the owl is above the ground is going to be 8.7 plus the 5 feet that accounts for the height of Gustav. So that's 7, and 8 and 5 is 13. So the owl is 13.7 feet above the ground. So the next problem describes a ladder that's 25 feet long that's leaning against the wall of a building. So let's start with our wall. So here's the wall of the building. We have the ground that's coming up to the wall, and the ladder is leaning against the side of the building like that. So the ladder is 25 feet long, and it says the angle the ladder makes with the wall is 80 degrees. The question is, what's the distance away from the base of the wall to the base of the ladder? So we'll call that x. So how far apart is the bottom of the ladder from the wall? Now that's important because that tells you whether it's a safe ladder to climb up or not. I don't remember what the rule is, but there is a specific setup if it's going to be safe. If it's too close, you might fall over backwards. If it's too far, I might slip down the wall. So if we look at this with 80 degrees, we're going to look at where we have the opposite side here and the hypotenuse. So this is going to be sine. So the sine of 80 degrees equals x over 25, and then x is going to be 25 times the sine of 80. So remember, make sure it's in degree mode, and then calculate that on your calculator. And it turns out that's 24.6, rounded to the tenths place. And this is in feet, so this would be 24.6 feet. So this brings up the difference between a diagram and a picture, right? So if you think about it, and I probably should have drawn the picture a little differently, but 80 degrees, this looks like even less than 30 degrees. My picture probably should have looked something like this, where if I had my wall, right, and because my answer 24.6 makes sense, but the picture does. I mean, my diagram could have been better. So let's say it that way. We'll be kind to Mr. Benson. So if I looked at this, And notice it didn't, having a bad diagram doesn't always mean you're going to have problems. So 80 degrees is going to be, that's on its way to 90. This angle right here is 90 degrees. So an 80 degree angle means that my ladder is going to be very low like this. It's going to be like that. In fact, it's kind of ridiculous, you'd have a ladder like that. But maybe they weren't going to climb it. Maybe they just leaned it against the wall. And so this is what the ladder would look like. The distance, on the ground and the distance on the ladder are pretty close. This is 25 feet, and this is only 24.6 feet. On the test, I'm going to ask you to make a video of yourself creating this table, and we talked about the patterns that are involved, and the patterns are this. We're going to start with sine, and we're going to do the square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. And that's the pattern, and then we simplify that. This is the pattern of sines. And so this first one is 0, so the sine of 0 is 0. The sine of 30 degrees is going to be 1/2. The sine of the 45 degrees is that square root of 2 over 2. Okay, it's irrational. The sine of 60 degrees is square root of 3 over 2. And the sine of 90 degrees is square root of 4 is 2, so this is 2 over 2, or 1, is 1. And then remember, the pattern for cosine goes the opposite direction. And so we're going to say, okay, so this will be 1, this will be 0, and this will be 1/2, and this will be the square root of 3 over 2 for 30 degrees of the cosine. And then 45, the cosine and the sine are the same, so this will be square root of 2 over 2. So that's how that pattern works. It's a very useful pattern. So the next problem is you have a line, this line N, it's in black, and it is in the coordinate plane. So we have that, and I want to find the slope of that line. This blue line here is just the horizontal, right? So this is like the angle of depression, like if I was looking here and I was looking down. And to find the slope, it's the same as the tangent. And so that was one of the cool things we learned about in trigonometry, is that we can find the tangent of an angle. So this happens to be 37 degrees, and that will give us the slope. Now this slope is going down, so we have to put a negative sign in front of that, and this is going to be equal to our slope. And so we can do that to 4 decimal places. And so we'll use our calculator, and it works out that the slope of this line, so the slope of line N is negative 0.7536 if I round up to the 10,000th place, the 4 decimals. So that's about 3/4. So I'm going down a little more than 3 every time I go over 4 to the right. The last problem has this girl Mia standing atop a 50-foot tall building. Her eyes are 4.5 feet above the rooftop. So really, when I'm thinking about this, the height of this triangle right here is actually 54.5 feet. And we want to know how far away is her friend down here from the building. Well, this angle right here is 59 degrees. We also can see that this angle on this triangle would also be 59 degrees. So I can use the fact that these are parallel lines, when her line of sight and this line of sight, so that she's going to have this triangle, which is 59 degrees down here by Pia, and I want to know this this distance right here, x. And I can see that using this 59 degrees here, this is the adjacent side, this is the opposite side. So I'm going to use the tangent. I'm going to say the tangent of 59 degrees is opposite, which is 54.5, over the adjacent, which is x. And then we're going to solve this. To solve this, remember, you're going to multiply by x, then you're going to divide by tangent of 59. So, and this really, what it works out to be is these switch places. So we're going to have x equals 54.5 divided by the tangent of 59. And we'll use the calculator for that. And it turns out that Pia is 34, or actually not 34, 32.7 feet away. So this is 32.7 feet away from the building. All right, if you have any particular questions, please send me an email and I'll try and get to them. Your test will be tomorrow.